Here's another word problem. Oregonville's population is about 55,000. If there is a projected annual growth rate of 2.5% t years from now, the population can be modeled A of t equals 55 e to the 0.025 t, where the population is measured in thousands. So you see here, when they say the population is measured in thousands, that's the reason why I don't have 55,000 there, because I'm going to already assume that my answer is in thousands. And then where do you see the 2.5% growth rate in the equation? Do you see that number anywhere? Yes, in the exponent. That's that percent as a decimal. So state the units on the horizontal axis. This is our horizontal axis. And what is this measuring? What units are we measuring? Yes, t is years. Okay, time in years. State the units on the vertical axis. What are we measuring here? Yes, and it's in thousands. Population in thousands. So that's why you don't see thousands on the end. Just saves you a lot of space so you don't have to have all those zeros. Now label the axes with the correct units. Notice that we're probably going to ask you to do this on some of the tests. This is something that people often forget to do. So we're labeling it, just putting years here. And then you can put on this axis population in thousands. Okay, evaluate A of 18. Plot and label that information on the graph. Interpret your results in a complete sentence. So anytime you have the number here, this is what year is this? Or actually, I should have asked you what does that number represent, the 18? 18 years. Good. 55e to the 0.025 times 18. So that t is getting replaced with 18. I'll go back to using my calculator for this. So I have 55. To get E, I have to go second ln. And now, for those of you with older calculators, you might start with parentheses here. I can put the parentheses in, but everything right now is staying in my exponent. So I have 0.025 times 18, close the parentheses, and that gives me what? Yeah, approximately. And where do we need to round to? What's that? Oh, so if I use 3 decimal places, what's the population, or how would you interpret this in a sentence? Yeah, after 18 years, because we're measuring time in years, the population is approximately 86,257. We don't want to round off to a decimal place. Do you see how I've turned my decimal into an actual thousands? Right. And so if we're going to plot and label this, here's 15. 18 is probably closer to 20. And if we go up to our graph, you can see that that's about 86. Okay, so here's 18. Didn't it say plot and label? Yes, 18, comma, 86. We'll just do 86 on the graph. Save space. Okay. This next question says, algebraically determine the number of years for the population to reach 70,000. You could pretty much look at your graph and see 70,000. It looks like it's going to be about 10 years, but let's find out. How would we do this algebraically? And instead of 70,000, we're setting equal to 70 because our equation is already in thousands. So 70, and this is, by the way, the same as solve A of t equals 70. I want to tell you that because that's a lot of times that kind of function notation is what kind of screws people up. But anyway, we're setting the whole equation, so 55e to the 0.025t. Okay, now how would we solve this algebraically? What would we need to do first? No, because 70 is the population, and remember we want to find, this is asking us to determine the number of years, and the number of years is the variable t, right? So this one we're going to solve. What should we do to solve? Divide by 55, okay? You could write that as a reduced fraction, or just leave it for now. I know they're both divisible by 5, though. Okay, e to the 0.025t. How can I get that out of the exponent? I want to use the, what's the log that has a base e? ln. So we take the ln of 70/55 is equal to 0.025t. Did I get t by itself? So what should I do next? Divide by 0.025, divide by 0.025, and that's going to give me t. T is approximately, because we probably are going to have to round, so let's use our calculator. I'm going to take the ln of 70 divided by 55, close parenthesis, and I'm going to divide that by 0.025. And I get 9.6. See, and we saw that on our graph that it was really close to 10. So 9.6, does it tell us where to round to? Let's just round to 2 decimal places. So what would be your sentence answer? After 9.65, after about 9.65 years, the population is 70,000. Okay, algebraically determine the number of years it will take for the population to double. Plot and label, interpret in a complete sentence. So, right, because, well, let's talk about this. So if the population doubled, what would it be? 110,000. So that would be 110 equals 55, because this is solve A of t, find the time when the population is 110,000. I'll just leave that off. 110,000 e to the 0.025t. Okay, now notice this is where this comes in, because you're going to see this on Connect Math. Sometimes they don't tell you where it starts. This is our initial amount, is the 55,000. But notice when you divide, you get 2, e to the 0.025t. If you had a problem that said, you know, the equation is a of t equals n sub 0 of e to the 0.025t, if they just said, they didn't give you the initial amount, we call this n sub 0 is the initial amount, right? And they just want to know, when does it double? All you would have to do is set it equal to 2 and solve, because you see what happens is when you divide out that number, you get 2 because it doubled, right? All right, now how do we solve this one? And by the way, actually, you know what I'm going to show you this time around? The same concept here is if I take the ln of both sides, because remember, I can do whatever I want so long as I do the same thing to both sides. So if I take the ln of 2 and I take the ln of e to the 0.025t, what's the ln of t? Or I'm sorry, the ln of e? It cancels out, and what's left? Yes, 0.025t. And how do we get rid of that? on both sides, 0.025 on both sides. And so in our calculator, we can put in ln of 2. Should I divide now or close the parenthesis? Ah, very good. And then divide by 0.025 equals t is approximately 27.73. So how long does it take for the population to double? It takes approximately 27.7 years for the population to double. Will that be what? Sorry? That number right there would, so that's a good question. Will the years be in thousands? What do you guys think? It won't be in thousands. But I had the same question in my head. I had to ask myself, is this number going to be in thousands? It's not, because it's time and only the population is in thousands. That's the reason why instead of using 110,000 here, we only used 110, because we eliminated the thousands part. And that just makes it easier on the graph so that your graph doesn't have a ton of zeros, you know. But and like it makes it easier for your equation too, because you're not dealing with all those zeros. Good question, though. Any other questions?